tutorial introduces classes with parameters. So now we're going to take, we had functions with parameters, and so we'd pass values into a function, and it would manipulate those values in the function. We ran into some trouble because we had local variables and global variables, and that was problematic because local variables couldn't be seen everywhere, and global variables overran everything. They had too much power. And so we're limiting. So now we've got a class which handles local variables extremely well and with great sort of nuance. So let's walk through this. First, you can see I'm scrolling up and down, and this is the entire block of code for the sketch. We're declaring two instances of the class. So we're calling the class, giving it a name. Then in the setup, we're instantiating the class. So we're saying this instance of the class is a new instance of the class. And then we're listing parameters. So if we look here, I've added notes here for the parameters. So we've got a color, an X position, a Y position, a speed for X, a speed for Y, and a diameter. And so order is very important. You have to make sure that you put these in the order in which they expect them. So 150 is the color, 50 is the X position, 50 is the Y position, 2.5 is the X speed, 3.7 is the Y speed, and 30 is the diameter. And then we do that again here for the second orb. Totally different set of numbers. It's slower, it's bigger, and it starts at 120 versus 50 and 50. So, and then down in the draw loop, we've just got the name of the class and the instance of the class. So for myOrb1, the first instance of the class, it's saying do this function of the class, and then myOrb1 do this function of the class, myOrb2 do this function of the class, myOrb2 do this function of the class. If we look here, another word for function is method. So if we look in the class here, what we can see is this is exactly as we described before. We've got the class called orb. We've got the 6 variables being declared along with their names. So C for color, X position, Y position, X speed, Y speed, diameter. So color can be, it doesn't just have to be one number, it can be multiple numbers. So we'll get to that a little bit later though. So, and then here, this is a bit confusing. So this is the constructor. So we declare the variables, and then this is the part in the class which actually catches the variables when they're passed from here. It catches them and places them into a temporary variable called color. And so it's passing it into temp C. It holds it in temp C. And so we have basically a temporary declaration of each of the variables we're expecting. So we've got I don't want to say the official variables. We had the variables that we're actually using in the code, and then we have these holders, which are basically just holding the code for a second. So really, and you can name them whatever you want, but it's useful to have some sort of just modifier that you're using, so you can keep track of C and temp C, X position and temp X position, right? So it passes the values when it's initiated here. It passes those values here, and these are holding that, and then directly below that it loads these values, the value of temp C, into the variable C, and the value of temp X position into the variable X position, and so on. Okay, and then it exits this. So this is only used for the construction for the first time that in setup that it's called. Okay, then we go into the methods of the class, or the functions of the class, and we have two. We have void display, which is no stroke, fill is the color, and ellipse is x position, y position, diameter, diameter. So, and those are all variables that are passed in the setup from here. So, and then the second is move x position, y position. Right, so we're iterating up. Again, unnecessary line of code. And then we're checking to see if it's reaching the boundaries. So again, there's not going to be anything shocking here. It's all going to be doing exactly what it's doing, except now we have two balls. They're moving at two different rates of speeds. Because there are no global variables driving this, we're not getting sort of that sort of linked behavior that we saw in the previous version before we were using classes. So they're completely delinked from each other. They have all the rules that they're following, but the parameters are what define how fast or how slow they move. So as sort of an illustration of the power of this, like one of the observations, right, is that when these are bouncing, they're hitting, they're not hitting the walls. And so what we would do is typically take the center and add or subtract half of the diameter to it. But these are two different diameters. So if we were writing the conditionals for that, we would actually have to write two different conditional tests. But in classes, all we have to do is go, okay, so if x position is greater than the width minus, and then we look, okay, diameter divided by 2. And if x position is less than 0, plus diameter divided by 2. And if height, if y position is greater than height, minus diameter divided by 2. And y position is less than 0 plus diameter divided by 2. This will automatically adjust for each of the instances of the class, because one instance has a 30 pixel width, so half of that is 15 pixels, and the other has 60. So let's make this even bigger. Let's make this like 100. So we run this. Oh, and see, this is, again, this is illustrating that we have to start inside of the values. So x position, y position, this is too small. So we'll just start them both in the middle to avoid getting trapped at the edges there. And you can write rules to make sure that they don't get trapped, but we'll just keep it simple right now. So now they should both start in the middle so they won't get trapped outside of the conditional statement. So that one's bouncing exactly when it should. It's getting trapped inside of the conditional again, so we have to fix that. But I think this demonstrates what's happening enough. So yeah, so you can see the value of this. So if we'll just get rid of this since it's creating some sort of issues, because I just want to add one more orb to see how quickly this goes, and I don't want to sort of massage this while I'm waiting to do that. Okay, so this is good. Save that. And then I'm just going to create two more orbs, and I'm going to give them new names, which means I also have to do that here. Right? Declare the instance of the class. Okay. And then I just have to duplicate this as well. So copy, and then go 3, 3, and 4, 4. Right, so it's marching through. We'll add some different numbers to this. Let's give this negative numbers so they're heading in different directions. Maybe make one really fast. We'll have this one also be negative. Maybe a negative and a positive. And we'll make it like a 4 and 2.5. And we'll change the size. Um, 75, 150. So because this variable in the class is a color, we can actually send three values out for this. So this, I think this is yellow. Am I in RGB? Yep. Okay, so let's see what happens. Oh. So null pointer exception says it's asking me to look at something that doesn't exist. So that suggests that my orb 4 doesn't exist. So I go back up through my naming. Yep. So I created it, and then I instantiated it. Oh, so here I forgot to add a 4 there. So that's probably the problem. I guess we'll find out in a second. Oh, there we go. Okay. So now it's working properly. So we've got, this is number 4. It's the big yellow one. So everything is moving along as expected. So this looks good. Okay, so that sort of illustrates classes at a most basic level. We're still doing a fair amount of heavy lifting here by declaring an instance of the data type orb from the class and then loading each one by one. But you can see once we start manipulating them, you can imagine how many conditionals you'd have to write. Each one would have to be manually written to address the diameter of each of the individual pieces. There are no global variables to speak of. These are the only global variables which are visible throughout the entire program. Everything else exists inside of the class. And so in terms of following this process, it's very simple. Name your class with a capital letter, declare the variables, create the constructor, and you're basically just copying this. The number of variables has to match here and here, and also when you load them. You can't not have a number. If I try and run this like this, see, well, you can see it already saying it needs another float. So we have to give it a float, and then it's happy. So, but basically just follow this construction. It will work every time. And then you write your methods based on the variables that you have. Your methods or functions. Okay. So that's it.